Hi, and welcome to our video on using the spectrophotometer. This lab was performed by Glenn Creighton, Michaela Cardwell, and Logan McMahon. That's me, and I'll be providing some pretty awful commentary along the way. Was this video made of chromium, iodine, nitrogen, and germanium? Because cringe. Okay, but no, really, let's get into some actual chemistry now. The first thing that we had to do before we could even get to use the spectrophotometer is prepare a series of dilutions using copper sulfate pentahydrate. The dark blue solution shown on the left side of the screen is our 0.02 molar stock solution of copper sulfate pentahydrate. Following it is our first dilution, followed by our second dilution. Shown here is our third dilution. Here is our solution of unknown concentration. Here is a picture of the lab notebook which shows all of the necessary calculations to find the molarities of each dilution using M1V1 equals M2V2. After making our stock solution in 3 dilutions, we had to fill our cuvettes. To fill the cuvettes, we transferred the solutions from the beaker to the cuvette using a transfer pipette. We did this for each individual solution, our unknown solution, and ammonia, which functioned as our blank. Using a blank to zero the spectrophotometer is necessary so that the ammonia in our solutions does not affect the absorption value. We ended up having 6 total cuvettes to put into the spectrophotometer. Here are our solutions with their corresponding cuvettes. Next, we took our solutions to the spectrophotometer. The first thing we had to do was zero the machine using our blank, then scan the absorbance values across all wavelengths using our stock. The main reason we do this is to find the lambda max, or the wavelength where absorbance is maximum. Another reason we do this is to see how the absorbance values change depending on the wavelength. This scan shows us that our lambda max lies between 500 and 600 nanometers. Now it was time to start finding our absorbance values. The first thing that we had to do was wipe the cuvette clean on 2 sides across from each other. Then we place our cuvette inside the spectrophotometer. Since we do not want the ammonia in our solutions to interfere with our absorption values, we first place the blank of ammonia in the machine and press 0 on the screen to zero the machine. Next, we will test our stock solution by placing the cuvette into the machine with the clean sides facing the light beams and then closing the door. We then press read on the computer and record the absorption value, which will be shown in the top left corner of the computer in red. We wipe down another cuvette containing one of our dilutions, making sure that it is clean on both sides, then place it inside the spectrophotometer and then close the door. Once again, we press read and record the absorbance value shown on the top left in red. After each read, we open the door, remove the cuvette from the spectrophotometer, and then close the door. Our lab notebooks also contain the Beer-Lambert law, which will be explained later, as well as a graph showing the relationship between the concentration and the absorbance values. It should be noted that as the concentration decreases, the absorbance decreases as well. For instance, our stock solution, which had the highest concentration of 0.02 molar, had an absorbance value of 0.8946, and it just decreased from there. Essentially, the Beer-Lambert law says that the absorption, represented by the capital A, is equal to the molar absorptivity, represented by the Greek letter epsilon, multiplied by the length of solution that the light passes through, represented by the lowercase l, multiplied by the concentration, represented by the lowercase c. The absorption and epsilon values can be found using the spectrophotometer, the length can be found by measuring the length of the cuvette, and the concentration can be found by finding the molarity of the substance. And of course, we couldn't leave this week's lab without cleaning up our lab area. All of our solutions and dilutions could be safely poured down the sink, so we poured everything in the cuvettes and everything in the beakers down the sink. Next, we just washed them out with water, and then we dried them off and put them back where they belong. I plan on adding some music here so that you didn't just have to watch us clean everything in silence, but I am severely unskilled in editing and didn't know how to do that. So I sincerely apologize that you just had to listen to my droning voice this entire video with no background music.